Hello everyone, this is another video from the page Chemistry Concepts. I would like to request for subscribing the channel and sharing the video with your friends. Okay, this is the last video in the continuation of electrophilic aromatic substitution reaction, and here the reaction is of sulfonation. The sulfonation reaction is just not that simple that sulfonic group will come or attack. No, definitely, like the previous video, we have generated an electrophile. Here we also would create an electrophile like sulfonium ion and that benzene pi electrons will attack over it. So firstly, we have to see that the first step, as you would have to be remember, that is generation of electrophile. So sulfuric acid react with sulfur trioxide. In the combined form, if we combine both of them, right, then the formula will be H2S2O7. Most of the books where you will see the reaction, you will see written H2S2O7. So this is the formula of these two, like sulfuric acid and sulfur trioxide. We know that sulfur trioxide will try to attract the proton of sulfuric acid. Because sulfuric acid is an acid, will give away its proton, and sulfur trioxide is very basic in nature, having pi electrons, having oxygen's lone pair, like huge electron density right there. So that will attack over the proton of the sulfuric acid, thus converting itself to be sulfonium ion. It is called sulfonium ion because sulfur is carrying a positive charge. And you know that whenever there is a positive center, it's an electrophile. It's a great point of any nucleophile to attack over it. So that positive site will be attacked by the benzene's pi electron. That would be the addition of electrophile. And as we have discussed in previously in 4 electrophilic substitution reactions, that sigma complex will form, or the carbocation resonance intermediates will generate. We have discussed them previously too. These resonating structure can be summarized in the form of a hybrid. This hybrid will undergo loss of proton. We have already discussed that the last step of any aromatic substitution reaction, electrophilic, is deprotonation, restoration of aromaticity. In the previous video, these lines were not mentioned. I told you that this is about restoration of aromaticity. The last step is always in order to achieve the stability. So here the sulfuric acid, which was eliminated as in the form of like this HSO4 negative charge, this will come again in the last step to abstract the proton generated as sulfuric acid. So here sulfuric acid is acting as a catalyst somewhere. It is acting as a catalyst to generate the sulfonium ion that it is used to. So main characteristic of the reaction is that here the active species is sulfur trioxide, not sulfuric acid. Sulfur trioxide is the main species which is being converted into electrophile with the help of sulfuric acid. So sulfuric acid has to be generated in the last step. Okay, this HSO4 negative will attack the proton. As a result, the bond will shift inside and we will have benzenesulfonic acid. We don't call it the parent name would not be benzene like the previous reactions, like we made nitrobenzene, like chlorobenzene, acetophenone, like acetobenzene, like this. Here it's called benzenesulfonic acid because this group has a higher priority when it comes to nomenclature. When you will need the nomenclature, you will need that some functional group needs to be preferred over the other one. So here the benzene is acting as a substituent or the parent over this main functional group, which is sulfonic acid group. So this was all about sulfonation, where in the first step there was generation of electrophile, like sulfur trioxide converted into an electrophile, which is sulfonium ion. That sulfonium ion was attacked by the pi electron of benzene, as a result generated sigma complex. and that sigma complex was about to summarized in the form of hybrid, and then this hybrid was attacked by HSO4, which was in the first step generated to regenerate the catalyst, and the final product benzenesulfonic acid was prepared. This was the last video in the series of electrophilic aromatic substitution reactions. I hope you would have liked all the video. Thanks for your support. Subscribe to the channel and share the video. Thank you.